Sorry about that, guys. Phone had some phone malfunction. I think I'm running out of space, so I need to kind of offload some of this stuff. But anyway, guys, so back to what I was saying. So what you're looking at here is where we left off on example number 2. We were doing long division. So we had just found by multiplying, substituting in 4 minus I and 4 plus I into a binomial, two binomials, we wound up with x squared minus 8x plus 17. So now we're going to do long division. So remember with long division, we'll take, since this is a trinomial, we're only going to deal with the first 3 terms, okay? So what we're going to do is we want to find out what can we multiply, because we're trying to get rid of get rid of this x to the third. So what can I multiply x to the second by to get x to the third? So the only thing I can do that is x. All right. So now we're going to multiply x times every term. So we're going to say x to the third, x to the second times x is x to the third. X to the x times negative 8x is negative 8x squared, and 17 times x is positive 17x. All right. So just like when we do regular division, if we were saying 6 divided by 7 or whatever, we have to change the signs. So everything changes to the opposite sign because we want to get rid of some things. So since this is a positive, this becomes now negative. This was negative, so it becomes positive. And because this was positive, this now becomes negative. All right? So these cancel out. Now we're going to say negative 5 plus 8 is positive 3x squared. So that, because again, negative 5 plus 8 is positive 3. And we just bring down the x squared. Negative 7x minus 17x becomes negative 24x. Okay? And then from there, we just bring down the 51. So now we need to figure out what can we multiply x squared by that we can get rid of 3x squared. So simpler, we're going to say 3. And because we're multiplying by 3, we're going to put positive 3 up here. Okay? So now we're going to multiply 3 times everything. So 3 times x squared is 3x squared. 3 times negative 8x is negative 24x. And then 3 times 17 is positive 51. And remember, we got to change the signs. So this now becomes negative, this becomes positive, and this becomes negative. Okay? So this cancels, leaving us 0. This cancels, leaving us 0. And this cancels, leaving us 0. So now we have our last factor, which is x plus 3. So now what we're going to do is we need to just solve x plus 3 for 0. So we're going to solve for x. So we're going to subtract 3 from both sides and give us x equals negative 3. So our factors, because remember what this question asks for, that's just for all the factors or zeros, sorry, not factors, all the zeros of this function. So our first 0 is x minus 3. We were given 4 minus I, but because of the conjugate theorem, the complex conjugate theorem, if we have 4 minus I, we also have 4 plus I. So that's our second 0, and that's our third 0. So we have 3 zeros for this particular problem. All right? So I apologize for the cutoff of it. So I'm just going to upload the 2. It'll just be part 1 and part 2. Okay? So now let's finish up the last one. Our last example says, write a polynomial function of least degree with integral coefficients whose zeros include 7 and 3 plus 2i. All right? So what that's saying here, guys, is that it's giving us our zeros. So we're basically going backwards. Like in example number 2, we had to find the zeros from the polynomial function. Now we're going to use the zeros that were given to find the polynomial function. All right? So again, this is going to be a little bit long one here too. So the example number 4. All right? So remember our zeros are 7, 3 plus 2i. Remember our complex conjugate. If we have 3 plus 2i, then that means 3 minus 2i is also a 0 of this particular polynomial function. So again, just like we did before, we're going to set it up going in reverse. Because this is a positive 7, when we make our binomial, it's going to be x minus 7. Okay? Then we're going to come over here and say x minus 3 plus 2i, because again we're doing the opposite, and then over here it's going to be x minus, parentheses, 3 minus 2i. Okay, so now that we have our three binomials, we're going to distribute, and then that will give us our polynomial. All right, so we can't do anything with x minus 7 right now, so we're going to just leave it to the side. We're going to go ahead and start doing FOIL, or double distributing, on each of these numbers. So if we say x times x, we're going to wind up with x squared. X times minus, parentheses, 3 minus 2i becomes negative x, 3 minus 2i. Okay, and then we're going to say x times negative, parentheses, 3 plus 2i becomes negative x, 3 plus 2i. Okay, and then lastly, we're left with x, negative, parentheses, 3 plus 2i minus negative, parentheses, 3 minus 2i, which two negatives give us a positive, so that becomes now 3 plus 2i times 3 minus 2i. Okay, so now those are all our terms. So now again we're going to distribute and combine like terms. So here we can't do anything with x squared, we're going to leave that as is. So we're going to distribute the minus x inside that and give us negative 3x, and negative x times negative 2i is negative 2ix. Okay, remember what I was saying, if you said negative 2xi, that'd be fine as well. But again, however you want to phrase it, I just go in alphabetical order. That makes it easier for me. All right, then we come over here. Negative x times 3, again, is negative 3x. Negative x times positive 2i is, I'm sorry, this should have been positive here. This would have been, because two negatives give me a positive, I apologize. So negative 2ix. Okay, so that takes care of that part. And then here, because these are conjugates, we're just going to multiply the first and last terms. And because it's positive, we're going to say 3 times 3 is 9. 2i times negative 2i gives us negative 4i squared. Okay, so now again we're going to combine like terms. So x squared doesn't have a like term, so we can't combine anything with it. We have negative 3x and negative 3x give us negative 6x. Positive 2ix and negative 2ix cancel out, because the two negative and positive, when you're adding them, and then the same number and same letters, they cancel out. So then we're going to bring down plus 9 minus 4i squared. Okay, so remember what I said about I squared, replace it with negative 1. So this becomes x minus 7, parentheses, x squared minus 6x plus 9 minus 4 times negative 1. All right, so negative 4 times negative 1 gives us positive 4. Sorry, getting a little ahead of myself. X squared minus 6x plus 9 plus 4. Okay, 9 plus 4 is 13. So it gives us x squared minus 6x plus 13. So remember, what we need is a polynomial in least degree, meaning that we only have, it's going to be one variable, and it's going to be a string of terms. We're not going to have any parentheses. All right, so here I'm going to do my box method, because again, it makes it a little easier for me when I'm dealing with trinomials. But however you want to do it is fine. It doesn't matter, as long as you distribute correctly all your terms. Okay. X times x gives us x to the third. X times negative 6x is negative 6x squared. X times 13 is 13x. And then we have negative 7 times x squared is negative 7x squared. Negative 7 times negative 6x is positive 42x. And negative 7 times 13 is negative 91. Okay? So x to the third doesn't have any like terms with it, so we're just going to write x to the third. We have negative 7x squared and negative 6x squared, which give us negative 13x squared. Positive 42x and positive 13x give us positive 55x. And then negative 91 doesn't have any like terms, So now we have successfully gone from 3 roots back to the original polynomial that they are roots or solutions of. Okay? So I apologize for these 2 videos. It was actually going to be about, actually it kind of worked out well because both of them turned out to be a little longer than I wanted to. But again, guys, that's basically it for all the videos that I'm going to make. There's some pre-made videos. I hope you find them useful. If you have questions, you know you can always ask. But again, good luck, and I'll see you in the next video. Bye.